This iPad was sent in to us from another repair shop. They told us that the customer used a cheap lightning cable and fried the device. This other repair shop also told us they tried replacing the charge IC, also known as TriStar. This did not solve the issue. The iPad will not charge or turn on. First thing we do is inspect the previous shop's work, measuring around the TriStar for any obvious short. Using diode mode with black probe on ground, we measure around the chip and everything appears to be absolutely fine. No shorts are found. Now we can use this TriStar testing tool and it will give us an idea on if the charge port or the charging IC is bad. Please note that these testers are not guaranteed to give accurate results. Regardless of that fact, they are still helpful in situations like this. It tells us that the port and charging IC are good. Now we will hook up the iPad to DC power supply, black clip on ground and red clip on positive pins of battery FPC. Set DC power supply to 4.2 volts and output. No amps prior to booting is normal. Plug in, charge port and prompt boot. Notice there is no change on DC power supply. As an alternative, we will try to prompt the boot using the power button. Check block diagram and identify which pin is the power button on this device. We identify it as pin 5, short it to ground with tweezers and hold for a few seconds, same way you would hold the power button to power on your device. See the DC power supply jump to over 200 milliamps and hold. This behavior suggests a short to ground. Let's take a look under thermal camera. We find the location of the short at this IC next to TriStar. Let's take a look under the microscope. This is the chip that we will remove. Let's set hot air station to 360 degrees Celsius and 50 wind speed. Proceed to remove the chip. Add some flux and preheat for a moment and then focus heat while applying upward pressure so that the chip removes itself at the exact moment the solder reaches melting point. Now that the chip is removed, we can clean the bonding pads and prepare the customer board for a replacement IC. Apply 138 degree low melt solder paste to your iron and tin each pad. Now cut a small piece of copper wick and hold it with tweezers. Set hot air down to 300 and, like a brush, go over and flatten each bonding pad. Switch to a donor board and pull a replacement chip. Put it in a fixture and make sure each pad is of uniform size. The trick here is to use a lot of flux and a lot of solder. We're going to create a blob of solder on the iron. That way we can go over each pad with the solder and not the iron. We're not ever going to physically touch the iron to the IC chip. That could cause damage. This is a safe and efficient way to prepare the IC for reballing. Grab a stencil and plant 183 degree solder paste with metal spludger. Dry it off and then hold with tweezers. Set hot air down to 300 degrees Celsius. Preheat the area and then focus at an angle at one of the corners to reball. As one final step to this process, we will hold the chip with tweezers and apply heat to reset each point. The IC is ready for installation. Apply a small amount of flux and place the chip. Do make sure it's orientated correctly. Once the chip's installed, clean it up and we are ready to test. One sec. Alligator clip fell off here. Okay, and we're back. Hook up to DC power supply and prompt to boot. Now we get what looks like a normal boot sequence. Let's grab an LCD and see if we can get to the operating system. No image. Checking under the scope, it appears our friend at the other shop accidentally knocked some components next to the LCD connector. Let's go ahead and fix that real quick. Alright, let's try this again. Now we get Apple logo on screen and make it to the operating system. Why is it sideways? So we thought the repair was done, but then noticed that this iPad is not charging at all. We also remember from earlier in the repair, when plugging in the lightning cable, it did not prompt the device to boot. That makes sense now. Before we go crazy replacing ports and charge ICs, I will show you how to properly diagnose this charging problem. Connect the board to power with a lightning cable, and we will measure where the port connects to the board on PPVBus USB. We're looking for 5 volts. We find 5 volts. Let's follow this voltage. We need it to reach TriStar. Measuring next to TriStar IC, we do find a problem. 3 volts. Check block diagram. We know we should have 5 volts on this line. Ask where this line could be dropping. First suspect is this resistor, R3533. Measuring the component, we see the correct 5 volts on one side, but 3 volts on the other. Unplug power from the board and switch multimeter to resistance mode. We measure 22 kilo ohms. Compare this reading to a donor board. Over here it reads 10 ohms. This means we have a bad resistor on the customer board and we must replace it. Now that the new resistor is installed, let's confirm the reading. We do in fact get 10 ohms on the customer board. This is good. Let's also check voltage. We now see the correct 5 volts on both sides of the resistor. We are ready to test for, I believe, the 3rd time. Is it charging? Is it going to start charging? Oh! Wait. Gotta realign the battery connector here. One sec. Did that work? Yes. Yes, it did. The iPad is charging. Now let's make sure it boots up to the operating system, and then we can pass it off to our front-end technicians for final testing and assembly. And there we go. Following all the repairs, this iPad appears to be fully functional. But my OCD is kicking in again. Why is it sideways? Wait, I have an idea. Oh, f it.